gives me a positive 2 times 4 is 8y squared. I just carry over what was out in front. And then finally distributing this into the last part, negative times positive is negative 2, and then y squared times y gives me y to the third, because y squared is y times y, and then times y is basically going to give you 3 y's multiplied together, which is y cubed. And also back in our briefing or our video on exponents, when you have variables multiplied together with exponents, you can just simply add the exponents. So 2 plus 1 is 3. That's why I got that. I'm not done yet. I've got a plus 2 times y cubed is simply 2y cubed, plus 2 times y squared is simply 2y squared. Okay? Now, this was a bunch of garbage on the screen here. So what do I do next? Well, the next thing I do is I try to find like terms, and I try to group them together, and I try to add them together. First thing that jumps out at me, this has a y squared, this has a y squared, and also this has a y squared. So I can simply add them together. 3 plus 8 is 11. 11 plus 2 is 13. So this is going to equal 13y squared. Notice there's some y squareds laying around in other places too, but because they have other variables stuck in front of them, they're not the same as this. They have to be exactly the same variable, exactly the same exponent, or I can't add them up. So I'm going to add 3 plus 8 gives me 11. 11 plus 2 gives me 13 y squareds. Now what else is the same? Well, I immediately notice that this term has a y cubed and this term has a y cubed. And it's 2y cubed minus 2y cubed. Anything minus itself is 0, so I'm just going to put a line through both of these. These two drop away. They cancel each other because this is positive 2y cubed, negative 2y cubed. And it's like 2 minus 2. You get 0. Okay? What else is left? This term and this term. Okay? Now let's rewrite this. This is worth rewriting. I'm going to just add a plus 3xy squared. I just rewrote this. Minus 2y squared x. Now, at first glance, these look different because they just look different. Here I've got an x times a y squared, and here I've got a y squared times an x. But if you think about it, they are really the same thing because I can rewrite this. And how can I rewrite it? I can rewrite it this way. 13y squared plus 3xy squared minus 2, and I'm going to flip these variables around, x times y squared. How can I do that, you say? Well, let me ask you something here. 3 times 4 is 12, right? 4 times 3 is also 12. When I multiply numbers together, it doesn't matter what order you do it. You get the same number. Multiplication is just like that. You can flip the order of anything. Here I've got y squared times x, but that's the same thing as x times y squared. I can flip the order of any multiplication. It just doesn't matter. And when I do that, now it matches. So this is a like term with this. So the final answer for this problem is 13y squared. 3 minus 2 is 1, so it's going to be positive 1xy squared. And I just don't write the 1 in front because it's sort of implied. So 13y squared plus xy squared. And that'll about do it for adding and subtracting polynomials. In the next course, in the next video, we're going to learn how to multiply polynomials.